So the main topics that were covered in this session were the trends and ecological trends in waters. And I put sheds in there as watersheds because really we talked more about water systems than sheds. And there was a lot of focus on cyanobacteria, obviously, because they are important. They're also indicators of eutrophication, water quality problems, health issues, and toxicity. Then we had a couple of presentations on protection and restoration, and climate change impacts filtered into each one of those, but they really were not specifically covered. So Microcystis is the cyanobacteria of the century, or maybe the millennium, as an indicator of eutrophication. And there were several talks that included this organism, including one that showed that through bird dispersion and other means, it is really present in almost every eutrophic system. And I just wanted to point out that this goes way beyond Asia. Of course, Asia is included, but we have North America, South America, somebody's sitting in front of Europe over there. And that's okay, Europe's pretty small. And, and Africa, of course. So this organism is a really good indicator, but it's also a really big problem in terms of being toxic, and then therefore the focus of a lot of development of indicators and also monitoring programs. The one thing I wanted to mention about Microcystis, and this came out in several talks that we had, was that in reference to nutrient supply, this organism responds to not just phosphorus, but nitrogen and phosphorus and nitrogen. And again, I want to drill home this issue that nitrogen, we should change the paradigm of eutrophication, or not change it, but just amend it to include both considerations of nitrogen and phosphorus. This is a really important management issue because as many managers and limnologists have been trained to just think about phosphorus in freshwater systems. That's no longer the case. We need to deal with nitrogen, which is a real challenge as well. And you can see it there on the experimental work that was shown. And I showed you some very simple stuff with filters and bioassays where you can see that the control here without any additions, nitrogen, phosphorus, N and P together. I think that this goes across many ecosystems, and we need to develop both indicators, obviously, and responses to this issue. The things in red here are probably the most important things that need to be measured in terms of looking at change in aquatic systems that involve this sort of big shift to cyanobacteria, and then of course analyzing the toxins themselves, and we've had some discussion about that. There are simple ways in places where we don't have sophisticated methods for measuring toxins to estimate them, and in my talk I showed you how you can use chlorophyll A as an estimator of potential toxicity from a drinking water perspective. This is the WHO level, acceptable level here for Lake Taihu, and you can see there are lots of instances where this is exceeded. And in many instances, when you don't have the resources or funds to measure those toxins, one can estimate them using a very simple indicator like chlorophyll. We talked a lot about mitigation strategies for dealing with cyanobacteria, but the conclusion, at least that I put across, was that no matter how you slice or dice it, you still have to deal with nutrient input reductions. There's no way to engineer your way out of this problem. It's really a fundamental issue of reducing nutrient inputs and managing them. Lake Biwa, I wanted to mention Lake Biwa because it is a success story. It is a good example of where strict reductions of nitrogen and phosphorus have led to improvement of water quality, not only in terms of the total N and total P, but the actual shift from a cyanobacteria-dominated system to one that's now more benthic, where macrophytes dominate. And I know that there's a dislike of too many macrophytes, but you know, if you have a choice between macrophytes or cyanobacterial blooms, I would pick macrophytes. So I think macrophytes are definitely an improvement. They're also a good fish habitat. We just have to now manage the system for controlling the macrophytes or managing them. And one reason for that is that macrophytes use sediment-based nutrients because they're rooted. And, you know, Biwa, like many other lakes, has a long history, legacy of nutrient loading that is stored up in the sediments. And you now have to wean the system off of those nutrients in the sediments. And that's probably why the macrophytes do so well there.
Okay, thank you. Is that the...
No, well, just a few more. Okay. So
no, it's like only one more slide, and that's the conclusion.
I want to include the other two talks, which dealt with contaminants. Okay, and we still have lots of issues and problems with contaminants. Not just developing indicators, but how to get rid of them and how to manage them and how to mitigate them. This is a real challenge, and wetlands really important as well. They're connected to lakes. They're the filters, as Ahmed said, the kidneys, I think, of filtering nutrients. And these are big challenges because we're just beginning to really start to deal with wetlands in terms of managing them. And then we have the climatic issue, of course, with drying and losing these habitats. So final slide. What have indicators done for us? They've allowed us to identify and quantify the linkages between the drivers and the responses of changes in the system over appropriate temporal and spatial scales. They're helping us develop solutions, prioritizing them to ensure recovery and sustainability. And there's good news. It's not all bad news. Okay? The good news is that we have good examples now of where these mitigation strategies work. That's really important because you have to overcome a lot of the skepticism out there of using these mitigation strategies. Engineering fixes alone aren't going to do the trick because you also have to consider the biogeochemistry and ecology. And then lastly, one reality trip is we're never going to get systems back to the way they were in most instances. This is the return to Neverland kind of thing. And that's because the baselines are shifting or have shifted. So we should be realistic in terms of what we can expect when we start to improve these systems. Thank you.